There are a few more things to say about angles in general a bit. So we talked a bit about degrees and radians. There's two ways to measure angles. We have 90 degrees. Also can be written as pi over 2 radians. And in general, if you have an angle which has no symbol on the end, it's in radians. So we default to radians. When we think about, when we try and draw angles, we'll use degrees often, but eventually we want to switch into radians, especially when we talk about revolutions and things like that. So degrees and radians. We also talk about an angle as being acute. And we'll talk about, say this angle here was theta. This is an acute angle. Acute means a lot of things in English, but here we're talking about it's less than less than 90 degrees. Similarly, we can have an angle that's bigger than 90 degrees. And this angle would be obtuse. Another commonly used English word. Not common, but has its own meaning. Obtuse just meaning larger than 90 degrees. We can have angles. And this sort of divides the circle up. All the acute angles are in the first quadrant. We use Roman numerals a lot for quadrants. Get to dust off your Roman numerals. These are quadrants. There's 4 of them. It's quad. You Star Trek fans will know the Alpha Quadrant, Gamma Quadrant, Alpha, Beta, Gamma, Delta, Delta Quadrant. Pretty cool. So these are the quadrants. All acute angles be in the first quadrant. This is the second. Sort of as the circle, as the angle increases, it goes through the 4 quadrants. That means angles can be very big. Like this one. That goes more than 270 degrees. It doesn't go 360. Say that's, I don't know, between 270 and 360. I don't know. It's 90 degrees. Let's make it 310. This could be 310 degrees. Also, we can measure degrees negatively. That makes sense. If that's 310, then this angle here, angle phi, can be 360 minus 310, minus 50 degrees. Alright, so we can talk about angles being negative. We can talk about them as being bigger than 90 degrees. They can actually even be bigger than 360 degrees. And this becomes important with rotations and things. We can have something rotate through a whole circle 360 degrees, 2 pi radians, and even go a little farther, or several revolutions. Like this one would be 360 plus another 40. Maybe this is 400 degrees. When we have an angle going larger than 360, its properties are the same as this angle here, which is going to be 40 degrees. And that's often called the reference angle, because the functions, sine, cosine, the trig functions related to that only care that it's 40 degrees. Similarly, minus 50 degree angles have the same function as 310, have the same functions as an angle that's 310 degrees. In fact, angles that add up to this and have the same terminal line are called coterminal. Term I do not want you to remember. Not terribly useful. Alright. So we have quadrants. We have angles larger than 360. We can talk about 5 pi. An angle that's 5 pi, that's going to go 2 pi, 4 pi, and then another pi. That's going to be the same as the reference angle for 180. Or reference angle of pi. Basically, you're just subtracting off bunches of 2 pi's. If it's degrees, you subtract off 360s until you get below 360. Or you can add 360 to it to get up to 310 and get the reference angle here. So, just different ways of measuring angles. You can see that they all naturally follow. There's nothing terribly weird here. We're going to talk a little bit, just a little bit more about measuring, say, the distance of this line. If we had a ruler, we could kind of maybe roll the ruler along here and measure it. But if we knew it was part of a circle, we can easily find this distance here, the circumference, right? If this was a radius, and this distance on the outside is going to be, remember this? 2 pi r. Yes, your good friend. What's the 2 pi there? It's not a coincidence that radians are in 2 pi and you have 2 pi r here. We'll talk more about that with the unit circle. But this thing here, a section of a circle, as long as it's definitely a circle part, it's called an arc. And we can get this length by finding the ratio of that to a circle. So we know that if this was a 360 degree angle, it would be equal to 2 pi r, right? But it's not. It's an angle theta. Well, let's make it like 50 degrees. It is 50 degrees, and it's this length x. So these things have the same ratio. Where this 360 down here, you could say that the length is 2 pi r. So we can solve this for x. This length of this line, this length of arc, length of x equals 2 pi r, and we'll multiply both sides by 50. 50 over 360. If we knew r, we could get a number out for that. And we could get the length of this piece of a circle. Okay, you can do similar things. Again, you can see if this was 360, it would be 360 over 360, which simplifies to 0. And you're left with just 2 pi r. Alright, so you can find a fraction of a circle's circumference. That's called an arc. Similarly, if you have a piece of pizza, you know this angle, you can say that what's the area of a circle? Sorry we missed pi day last week. We were in logarithms, so we didn't care about pi last week. But we do care this week. Area again is pi r squared. If that was 360 degrees, then our area, call it y. Let's make some this area in here. Y. It's going to be related to our angle theta. So it's going to be a fraction of that, or we can just write y equals theta over 360 pi r squared. If we're dealing with radians, we don't use 360. We would use theta over 2 pi r squared. And similarly for this one, it would be theta over 2 pi r. Alright, notice that cancels out. It's not a coincidence. That's one of the reasons we use that. Things simplify if we're doing some things in radians. We still like to think pretty much in degrees, so we'll switch back and forth between the two. But here you can find arcs, and this is called a sector. I always confuse this with quadrant. I think it's from watching too much Star Trek. This is called a sector here, and this is called an arc. So we have angles bigger than 360, bigger than 2 pi. We have negative angles, we have acute angles, obtuse angles, coterminal angles, sectors, quadrants. All new terms, but probably something you've heard before.